Bom, bem-vindo todo mundo, podem se assentar. Eu vou esperar todo mundo estar sentado, confortável. But I will do this talk in English because it will be recorded, okay? I'm a Brazilian, I speak Portuguese, of course, but yeah, I will do it in English. So, well, I'm really happy to be here and I have a packed room. So before we start, let me take a selfie with you. And I will publish this picture of us in my Twitter handle. I think Victor will switch. Yeah. I don't know if you, at the end, can see the link here, but that's the link for my Twitter, where I will publish this picture and also the slides. In fact, let me take the picture, then I will start. Say hi. Woohoo! Okay, where is Bruno? Bruno said that he would give away some Azure credentials. Yeah, well. The slides that I will use today, they are available online in this link. Let me see if I can increase a little bit. It's available here because I have several references, I have several links to the demo, links to articles, and probably you need and want to get these links. So if you are interested on the slides, you can get it now, okay? This talk is about how serverless can complement microservices, okay? For those who don't know me, my name is Rafael Benevides. As I said, I'm Brazilian. My grandfather was Portuguese. You can see it by my last name, Benevides. I worked for Red Hat for almost 9 years. And essentially, I'm a Java developer. I work there as a director of developer experience, which means that I help developers worldwide to improve their development skills with Red Hat products and also with DevOps practices and things related with containers and OpenShift, Kubernetes, and those things. But essentially, I'm a Java developer, okay? Well, and because I work at Red Hat, I would like to invite you here, everyone, to join the developers.redhat.com. There you will find resources like free ebooks, like the books like developing, building reactive microservices in Java, microservices for Java developers. You can also get the book Migrating Microservice Database from Edson Yanaga. He has a section today. And he's also at the Red Hat booth. You can meet him and talk to him about microservices and databases. There's also introducing ICO service mesh for microservices. But as I said, it's all free. You just need to sign up to download. Okay, and I promise, we will not spam you every day. It's like you receive an email once a month with the best topics from that month and with the news about software development. So it's really, really nice. It's for free. This talk that I'm doing today is based on a keynote that happened, Red Hat Summit 2018, that happened last month. So this talk is based on the keynote demo that happened there. So it's really cool because you can see how functions can help microservices and microservice architecture. Well, I like this phrase from this blonde guy here, Thor. he says that in a movie, of course, he said, our ancestors call it magic, but you call it science, computer science. I come from a land where they are one and the same. And we will feel somehow that sometimes when we are doing some practices like functions, for example, with serverless, sometimes we think that is kind of magic, but of course it's all computer science. For many, many years, we developed monolith applications. They were nice and easy to develop, easy to deploy because you deploy just one single block. But sometimes, in a moment in time, we realized that it was good to have modules, that we should split our application and have boundaries of our sales part of the application, warehouse management, finance. They are all parts, they are all modules of our big monolith. And then with modules, there was a time that we decided to move to a microservice architecture. Sorry. Of course, we could deploy those microservices in a single machine, but the idea is that we can have those microservices independently deployable. That's the beauty of microservices. I can deploy them independently in different servers and use different technologies. I can build a microservice, one microservice using Java, another one using Node, another one using Python, another one using Go, and then we can spread them across our network. Of course, since they are spread in a network, we need a network of services. Of course, every microservice needs to have their own database. That's a kind of premise, because remember, they are independently deployable. And some of them, most of them, will have multiple points of entry. But we tend to forget about the fallacies of distributed computing. Sometimes we forgot that the network will fail. It's not that it may fail, it might fail. It will fail at any moment. We should be prepared for that. We forgot sometimes that the latency is 0. We tend to think that the bandwidth is infinite, that the topology does not change. We think that there is one administrator, and we cannot expect that we have one administrator, because most of the time they need to take vacation. There's one guy that takes care about the security, another one that takes care about the deployment, another one takes care about the virtual machines. So we have to talk to different teams and different administrators. We forgot also that transport cost we think that the transport cost is 0 and the network 0, and the network is homogeneous. All of these fallacies are mentioned on this Wikipedia link, and of course that's all those things that I mentioned potentially will become a problem when you spread your microservice through a network. Okay, so we want to avoid a problem. We want to avoid that one fail in a service can cause a cascading failure. And to avoid that failure, we have to embed some capabilities inside microservice. We need to, besides having service discovery, having load balancing, we need to also embed, for example, circuit breakers, fault tolerance, and if we need to measure, to embed metrics, tracing. They are all parts of a service, of a microservice. And usually for Java application, we tend to use a library from Netflix. We can see that the microservice history is not something recent. There was a movement that started, of course, with Netflix moving to AWS in 2012. Then it came Ribbon, Histrix on March of 2012, Eureka for service discovery. And finally, in March of 2012, Microservice Assist ThoughtWorks Radar. Then Docker came later, Spring Boot, and then finally microservice was defined by Martin Fowler at ThoughtWorks. So we can see that's not something new, that's not new, but everything was created based on Netflix OSS, as I said before. But what's wrong with Netflix OSS? Well, the problem is that it's Java only. So you need to add a lot of libraries to your code to perform all those things that I said, like circuit breaker, service discovery, traceability, tracing, metrics. So the problem is that every service that you deploy, for each one of them, for each microservice, no matter if it's a JavaScript application built using Node.js, Go, Vertex, Wildfly Swarm, Spring Boot, they all need to have their own API well-defined, but you need also to concern about how you will do the discovery of that service, how you will invoke that service, how you will handle the elasticity, resilience, the pipeline to deploy that microservice, how you will authenticate against that microservice, how you will perform logging, monitoring, tracing. And fortunately, some of these microservices or microservice capabilities can be performed by Kubernetes and OpenShift. So for example, discovery and invocation and elasticity can be performed by Kubernetes because Kubernetes has a built-in support for service location. Some other things like monitoring, logging, and pipeline can be provided by OpenShift. And the rest can be implemented using ISTO. ISTO is a service mesh implementation. What is a service mesh? It's infrastructure that allows you to have a fleet of proxies that can be managed centralized. And once that you can manage them centralized, then you can use those proxies to intercept the call and perform functions. I will demo that using this website here called learn.openshift.com/servicemesh. Okay. While I explain how ISTO works, I will create here, I will get an advanced route rules so you can have an idea how ISTO works. So first I will install some microservice, and while it's installing this microservice, let's continue our presentation. So ISTO can fill the gap by providing built-in monitoring, built-in tracing, built-in discoveries, resilience, and even mutual authentication with mutual TLS using certificates between the microservices. So before ISTO, you had, as I said, a library that provided everything for your application. Inside your application, inside Service A, you had discovery, load balance, resilience, metrics, and tracing for every microservice. Then, after ISTO, you have those capabilities inside a sidecar container. So a sidecar container will provide those features to the service. You don't need to implement that for every microservice, because the the sidecar will intercept all network traffic and then redirect the traffic to Envoy. Envoy is a proxy written by Lyft. Let me share the link here with you. Envoyproxy.io. So it's an open source proxy designed for cloud native application. You can see that's used by, it was created by Lyft, but it's used for many vendors. So the idea is once that the traffic arrives at the proxy, at Envoy, you can have things like intelligent routing and load balancing. So you can perform A/B testing. We will see that working. You can perform smarter canary releases. You can even perform chaos testing by introducing fault on your microservice, so you can see how it behaves. You can have built-in circuit breakers. You can have built-in metrics and tracing, and that's all managed in a fleet-wide policy enforcement. So how that works? As I said, every microservice will have a sidecar container with Envoy. And inside the Kubernetes cluster, you will deploy a control plane that uses ISTO pilot, mixer, and CA, which provides the mutual authentication. So let's see a demo here of ISTO. So I have installed here some microservices. It's a microservice called customer that invokes preference, that invokes the version 1 and version 2 of recommendation. Okay, so if I just try this microservice here using a curl command, let's see the reply. While true, yeah, you can see here that the customer will invoke preference, that will invoke recommendation. And because I have two versions of recommendation, I will see a reply from version 1 and from version 2. With Envoy, I can, for example, how many of you are familiar with Kubernetes? Raise your hand. Okay, so you can write a rule using YAML, just like a Kubernetes, but you can say, for example, I want that all my, everything that the destination is recommendation, I want to send to version 1. So let's apply this route rule here. So we can apply the route rule, and if we try again, oops, now we can see that we have only v1 replying, because I applied that route rule to my cluster, and then the proxy will intercept and only send request to version 1. And of course, I can have something like smart routing based on user agent header. So I have another route rule here that based on the header, if the header contains Safari, then I will see the version 2. So I'm applying that route rule. I have applied that before. And if I just keep rolling here my curl command, I will see version 1. But if I open my URL, I will see version 2, because I'm using Safari. If I use Firefox, for example, let's open Firefox here, I will see version 1. So that's the power of ISTO. Let's see something else that we can do. So I can, for example, in a curl, I can inform the agent here. So if I inform Safari, I will see v2. If I inform the agent Firefox, I will see v1. So let's remove that route rule and see another thing that we can do with ISTO. Today at the keynote, we saw Stephen talking about dark launches. Have you heard about dark launches before the keynote today? Well, one of the greatest examples of dark launches was the Facebook Messenger. Facebook Messenger was released 1 year before we seen it live. So how they did it? Well, they routed every post that you wrote, they routed it to the Facebook Messenger, but you never saw it. So that way they could test failures, they could test how scalable it was, just because they mirrored the traffic to Facebook Messenger. So with ISTO, you can do the same thing. So for example, we see here that we have two versions of recommendation. We have version 1 and version 2. And I can apply the following route rule. I can say, well, route everything to V1, but mirror the request to V2. So the request will arrive at V2, but we will never see the response. So let me apply that route rule here. I will say that I want everything mirrored, and then I can try now the version. I see only version 1 being responded. It's only version 1 that's replying, but I can open the log for version 2. Okay, and I can see that in version 2, I'm also receiving the request. Because I'm looking at the logs. If I look here at the invocation, I just have the reply from V1, but if I look at the logs of V2, V2 is also receiving the request. So that's also another example of power, of the power of using ISTO to manage your service mesh. So this is really nice. And you can have, for example, let me delete this route rule. Okay, now that I deleted the route rule, I can see V1 and V2 again. I can have, for example, access control, whitelist and blacklist of services. That's really, really nice for a situation where you need to manage the invocation from one service to another. Imagine that you have 100 of servers. Okay, so ISTO is really nice, but I like also this phrase from Spock. Change is the essential process of all existence. So let there be functions. For a certain moment in time, we only handled microservice. It's on your control. You choose where to deploy, how to deploy. You choose the language. You choose the database. Usually, they can be used for a long-lived process. It's not only that they are for a long-lived process, but they can be used for a long-lived process. Like, for example, if you open a WebSocket to a microservice, that's an example of long-lived process. So as I told you, you choose the programming model. Often is a sync request response. It's mature because you have IDs, you have debuggers, you have traces monitoring, and CI/CD. But with serverless, it's not under your control. It's the cloud that will control the creation of the container that will run your function and choose the best moment to drop it. So because of that, it's good for a short-lived process. You just execute one thing, and then it's gone. And of course, it involves a new programming model. Of course, you can write functions using Node. You can write functions using Java, as you see in the later demo. But you change the way that you program. You will not program like in an object-oriented way. you will program more like in a function way. And because of its nature of being stateless, it's most used for event-driven async invocation. It's mature because it's something new. We don't have many IDE supports. There are different vendors. We don't know how to perform debugging. So all these things is still a question, incognito. So we need to find out as more we use about serverless. So the definition of serverless is basically when you have a backend as a service. You don't need to have a server always turned on. That's why it's called serverless. You just need to provide a code, and then when that function is invoked, then the cloud will provision an infrastructure to run that function, and then it will die. But it's serverless because of service as a service. I like this meme. What if I told you there are servers in serverless? Well, as I asked to all of you during the keynote, you have to ask yourselves about a service. Is there anything that I can buy, or do I need to build something? Because most of cloud providers they have things that you can buy from them. For example, and you will see that's all about service. You can buy HTTP input and output service. All the cloud providers have support for that. Then you can buy authentication service. You can buy also file storage service. You can buy data services, like cache as a service, database as a service. You can buy connectivity services, like notification as a service API, messaging as a service. Then you will provide your containerized services. You write your microservices to integrate with those existing services. And then you can use functions as an event-driven input to make the glue between one microservice and another. And that will make you able to tie and to have those functions fill in the gap between the service that you can buy and the service that you wrote. Okay? And of course, not only for input, but also you can have functions for output. That will create a synergy for your application and for your infrastructure. There are some players, Stephen mentioned that. So Stephen mentioned Kubernetes, mentioned at the FN project, but OpenFast. There is also Fission, Riff from Pivotal, but I will focus this presentation on Apache OpenWhisk because it can run on a Kubernetes cluster. And you see that's really, really nice. Of course, when you have everything on-premise, when you have everything installed on your corporation or in a data center, you have to take care of everything. You have to take care about the virtualization, the server storage, and even the business logic. As more that you move to the right-hand side, you will see that you have to, you will need to be less. You need to concern less about infrastructure and worry more about the business logic. So when you have something as a function as a service, you just need to concern about the business logic. So why Apache OpenWhisk? Well, it's an open source project. Red Hat is all about open source. Something that I like about OpenWhisk is because it supports many languages. So it supports JavaScript, Swift, Java. We are all Java developers here, right? Python, PHP, Docker, Go. And you can deploy that on any platform where Docker can be run, or in this case of my demo, using Kubernetes and OpenShift. So let's start, for example, with a function written in JavaScript. So this is very straightforward. You can see that it's not complex. You have a function that receives a lot of parameters. You can send an array of parameters. Then you can do anything that you want with that parameter, and then return a JSON payload, a string. It's up to you. Okay? To create a function using OpenWhisk, let's do an example here. To use OpenWhisk, I can use a WSK, which is the OpenWhisk command, and then I can do something, for example, WSK action list. That will list the existing actions. I have some predefined actions here. Like, for example, I have a sample called greeting. It's written in Node.js. So I can do, for example, WSK action get greeting. So that will give me all the information about that function. The version, the runtime environment uses Node.js, so it returns a friendly greeting. There is a sample output here, which is a sample output would be payload, hello, cat from Narrowsburg. A sample input where you can provide a payload and a place. And you can see the parameters for that function. The name and the place. So to invoke that function, I will use WSK action invoke, and I can provide those parameters. I can say parameter name Rafael and parameter place JNation. And that was invoked on the system, but I didn't get the answer. In fact, you can see here in the log that it returned that the greeting was invoked with those parameters and the name. If I want to get the answer in a sync way, I can say -- result. So I can see here, hello, Rafael from JNation. In that case, where I didn't provide the -- result, I can get the result using WSK activation get and the ID of the activation. That will show to me the result. Hello, Rafael from JNation. So you can get the return at the same time or later. Okay? So what about this is a sample, but let's get here a message action using JavaScript, right? Function, main, it's the same one that I showed to you in the slides. So to create a new action using JavaScript, it's easy. WSK action create, and I will give a name here, message action, and then I just inform the name of the file. That's it. Now that the action was created, I can invoke my message action using the parameter body, text my stuff, and ask for the result. So I can see here JavaScript on OpenWhisk on OpenShift plus the parameter, my stuff. What if I decide to replace the JavaScript implementation by Java, by Python? I have also here message action.py. So this is implementation using Python. Same thing. It receives parameters and it provides a payload. So instead of create, I will update the message action, and instead of the JavaScript, I will provide Python. And I will perform the same invocation with the same parameter, and I will see the result here. Python on OpenWhisk, on OpenShift, my stuff. So you can see that no matter if I wrote my function using Python or JavaScript, I can provide the same invocation, and I will get, of course, different results. It's just a matter of the parameter that I used. If I want to return to JavaScript, OK, update, invoke again, JavaScript on OpenWhisk. Very straightforward. What about Java? We are in a Java conference talking about Java. So Java, to help providing Java functions, you can, there is a Maven archetype that you can use. So you can clone that from this Git repo, then go into the Java action archetype and install it locally. I have done that before during my tests. So I can use a Maven archetype generate to scaffold a Maven Java project. So let's do that. Let's create a Java project. Oh, that already exists. Action Java. Let's create. You can see here that's a Maven project. It's a little bit small, but you just need to see that's very simple class with a main function that receives an argument as a JSON object, and then it will reply, greetings, hello, welcome to OpenWhisk. So let's deploy that function. So I'll cd action Java, Maven clean package to create the jar file. And now it's a little bit different to deploy an action written in Java. You will need to provide the jar file and also, of course, the main function that will be invoked. Okay, now I have my function written in Java, so let's invoke it. Ask for the result. Greetings, hello, welcome to OpenWhisk. And you can see that if I invoke it multiple times, oh, come on, it's really fast. You don't have that bootstrap time of the many Java virtual machines, because when you invoke it, what happens inside the OpenShift or inside the Kubernetes cluster? Let me go here and ask to see all pods. You can see there are some pre-warm pods deployed for those actions. So I can ask here, I want to see all pods with the status in active. So let me invoke here, and you should see it creates the pod, and then after some seconds, it will remove that pod from the active. So it keeps some pre-warm pods to invoke, and at the end, it will just remove. That's why it's called serverless. You are not managing. Someone turns on the server and turns off at the end of the invocation. That helps you to reduce the costs of your infrastructure. Of course, you can have something like, for example, you can have web actions. So if I specify here web equals true when I'm creating the function, that will give me a URL that I can invoke. So I have this -- URL that I can open, ask here for .json. Of course, it will complain about the self-signed certificate, but I can say proceed. Yes. Hello, welcome to OpenWhisk. So that function was invoked by the web. Of course, I can send parameters using HTTP posts to that message. Something that it's really nice, it's a sequence of action. Imagine, for example, that you have a message that will split your string in an array. So I can, of course, I have a previously deployed here an action in a package called Red Hat developers-demo splitter, and I will send some parameters here. Let's start with Rafael, Benevides, what else? JNation, Java, Coimbra, and ask for the result, and write that result in a file called split.json. So you see that it splitted the one single string in many in many separated strings. Then I can invoke another function to sort, right? So I can use that file from the previous version as a parameter. So I will sort that and write the result in a file called sorted.json. So now it's alphabetically sorted, and the result was written in sorted.json. Finally, I can turn everything in lowercase. The same thing, I can use everything from that parameter file, get the result, and I will see here everything in uppercase. But that seems a little bit hard because I have to create, invoke 3 times. What OpenWhisk allows me to do is to create an action based on a sequence. So I can create an action inside that package that I called split, upper, and sort, and I inform the sequence. Please invoke splitter, uppercase, and then finally sorter. Oh, I already have that action. I can use update if it already exists. And then I can invoke that action using the same parameters that I had before. So we can use Rafael, Benevides, JNation, Java, Coimbra, Jug, what else? Portugal. And you can see that all functions was invoked once, just from a single existent function. So let me keep this window here, and you can see that it invoked sorter, upcaser, and splitter. It gets the result from their activation and provides the result to you. So this is one example of OpenWhisk that's really nice to have sequence action. What else we have in the function world? So some terms for you to get familiar. We have actions, as we saw, with a stateless code that we executed, functions. We can have packages to group functions that are similar. We can have feeds that acts as an interface that will feed the function ecosystem. We have triggers that, of course, it's an external stimulus. We can have rules that it makes a tie between the trigger and to an action and vice versa. And we have the activation, as we saw previously. Every invocation gives you an activation. It's a record of the output responding output of the response of running or ran actions. So let's see an example here that's a little bit more complex. So I have a demo here where I will post a message in a broker, in an active MQ. Then there will be a feed that will trigger the function, a sequence function, and post a message back to active MQ. That example is written here. So in this case, I have written functions using different languages. So to split, I used Python. To sort, I used Go. To turn to uppercase, I used Java. And to send the message back to ActiveMQ, I used JavaScript. I have already deployed those functions, so I can do, for example, WSK package list. Let me get here. WSK package list. Nope. Let me create an alias here. I can see some packages. I have a package key here called message demo. So we can also do a package get and ask to see the content of that package. And we can see some interesting things here. A package can have parameters, for example. So I have a set of parameters here that are available to all functions. So I have the broker host, the broker port. All those parameters here are already available to the following actions. So I have the message sender that will send the message back to the to Apache to ActiveMQ. Thank you. It's written in Node.js. We have the sorter, which is written in Go, uppercase written in Java, the splitter written in Python. So let's do the following. First things first. We need to create a feed, a trigger. A trigger will do the following. It will listen for everything that I post on the Q99. Let me increase here. The parameter, it's address, connection options that I also defined here, and the Q is the Q99. Now everything that I post on the Q99, it will trigger something. Now we need to create the sequence using the existing functions that I told to you. The splitter, the uppercase, the sorter, and finally the sender. Okay, so I created a message called split sort uppercase, and finally I will create a rule that matches both. So every time that the trigger Q99 is triggered, it will invoke the split sort uppercase function. Okay, so that's the glue. Now let's do the following. Let's keep listening for the reply queue JNation with J and N capital. So this node application will listen for this reply queue. Okay, and now finally we can invoke. We can use another node application which is called demo send that will post on the Q99 the following parameters here. So let's play. Let's write again. Rafael, Java, Benevides, Coimbra, Portugal, what else? JNation, what else? Julio. Who else do I know here? Yeah, Victor. Okay, so it's enough. And let's send another parameter here, which is reply to reply JNation. Yeah. So we'll post something to Apache MQ. The message was accepted by the peer. We can see the activation here. And here you go. It was sent back to that queue reply JNation. We can even see that in the pod. Let's invoke here. So the 4 pods was created, one for each function. And finally, we see the result. So this is really nice to show how you can use functions to implement, to make the glue between one microservice and another. Of course, it's good to know that at this moment there is no specification, but there is an initiative called Cloud Functions that will provide a specification for cloud events, and this effort is managed by CNCF Serverless Working Group. If you are curious about this function tutorial, you can run it locally on your machine. You can come here to this GitHub repo. Remember, I will share the slides with you. And you can try web functions, chaining actions. You can try the advanced part with the Apache AMQ that I did. Or you can come here to learn.openshift.com/serverless. Serverless. Then if you don't need to install anything locally. You just come here, start a scenario that will connect you to an environment that will have OpenWhisk already running. You can try and create a function to yourself. Okay, so thank you so much. We are out of time, but I really appreciate your time here and this full room. So thank you. One or two questions.
Okay. One question about.
Okay.
If you need to use web sockets, it's you have an easy way, because in AWS is a nightmare. I need to use IoT Cloud to use web sockets to trigger these functions.
Yeah, I don't think it's hard, because as you can see, you can have web function, and then you can post a message or invoke it internally, or well, I really don't think that's hard, because you can have support for web actions.
Yeah.
But then the problem is, once that you have the WebSock established,
Exactly.
then probably you need to send something back to the browser, and the browser will open a request to that function. Something more async.
Yes. Okay. Thank you.
Thank you.